Hi everyone, we are David Osowiecki and Gustavo Vargas Hakim, and this is our work NC-TTT, a noise contrastive approach for test time training. This paper was made at Livia, the Laboratory of Imaging, Vision, and Artificial Intelligence in Montreal, and under the supervision of Ismail Benayed and Christian Degossier. Deep neural networks are fragile to the problem of domain shift at test time. The goal of test time adaptation is to take a model trained on a labeled source domain and adapt it to an unlabeled target domain with a different distribution. Test-time training is a popular approach for test-time adaptation. It uses a Y-shaped architecture where an auxiliary task will be plugged to the original model during training. Then, the auxiliary model will be used to update the feature extractor at test time to improve the performance of the model. Recent approaches involve rotation prediction, contrastive learning, normalizing flows, and clustering as auxiliary tasks. In an ideal scenario, we could measure the likelihood of a test sample by comparing it with the source distribution model using kernel density estimation. However, the source domain is not available at test time. To approximate the source distribution during the training phase, we use noise contrastive estimation between in-distribution and out-of-distribution views of training samples. Our method, NC-TTT, applies noise sample from two Gaussian distributions with zero mean and different variances to the projected feature vectors. A discriminator learns to classify between both noisy views. The problem is that the noise samples overlap as both distributions have the same center. To avoid confusing the discriminator, we use a change of variable to approximate the likelihood function and avoid instabilities. We use the sigmoid to assign soft labels to each noise sample and finalize by use cross-entropy as the auxiliary loss. Please visit our paper for a more detailed theoretical formulation. This is an example of noise features that overlap and their corresponding probabilistic soft labels on the right. We evaluate our method on common corruptions represented by CVPR dataset, which includes 15 different corruptions, each of them with 5 severity levels, yielding to 75 scenarios. NC-TTT achieves to defeat previous methods in most categories and at all the different levels of severity. We evaluate our method on the simulated to real domain shift using VISTA-C dataset. The model is trained on 3D renderings and then adapted to video frames. We observe a performance improvement with respect to cluster tree, the closest competitor, as well as other previous approaches. Future work includes exploring other types of noise that could potentially improve the contrastive representation of source and target domains. Moreover, a fundamental question covering all test and training methods still remains. What are the mechanisms that make an auxiliary task better than another? And how can these tasks link better to the main classification task? Answering this could lead to the development of more suitable TTT methods and help deploy models to new domains. Thanks for watching, and do not hesitate contacting us if you have any further questions.